Hello everyone, I'm Kyle Yoo and welcome to IB Physics. Today's class is about projectile motion. Projectile motion is a 2D kinematic problem where an object is launched at a certain angle, which is theta here. Object's initial velocity, which is v0, can be divided into two components, which are vertical and horizontal. Vertical components of the velocity can be expressed like this because sine theta is v0 y over v0. Similarly, v0 x can be expressed as v0 cosine theta. In projectile motion, there is no horizontal acceleration. So v0 x is same as Vx, which means that Vx is constant throughout the whole motion. So for horizontal velocity, Vx is always constant, but Vy is not always constant because there is vertical acceleration. The vertical acceleration in here is actually gravitational acceleration, which points downward throughout the whole motion. So if I draw some acceleration vectors here, it can be drawn like this, and A is written as minus g because g is acting downwards in projectile motion. And I'm just gonna draw only 4 letters here, but this acceleration vector, this acceleration actually exists throughout the whole motion. So as the object travels through this path, velocity vector is always tangent to this path, like this. So velocity vector is always tangent to this path, and then at the top of the projectile, the velocity vector is completely horizontal, which means that at the top of the projectile, Vy is equal to 0. Okay, so let's solve some problems related to projectile motion. Okay, so let's calculate total time. In order to calculate total time, you need to notice that in projectile motion, there is complete symmetry. So the time it takes for the object to travel from the moment it's launched until it reaches to the top of the projectile is identical to the time it takes for the object to travel from the top to the bottom. So it is completely symmetrical, which means that the total time is just 2 times this small t. In order to calculate small t, we need to use one of big 5 equation, which is Vf is equal to V0 plus At. In here, we are only considering vertical components of the velocity. So, and we are going to find t using this section of the projectile. Therefore, Vf is Vy at the top, which is 0, and V0 is V0 y, and A is minus g. Therefore, 0 is equal to V0 y minus gt. So gt is equal to V0 y, and t is V0 y over g. And since V0 y is V0 cosine theta, it's V0 cosine. Since V0 y is V0 sine theta, t is V0 sine theta over g. And since big T is equal to 2 times small t, the total time, which is big T, is equal to 2v0 sine theta over g. Let's go on to the next question. So the total time is 2 v naught sine theta over g. Then let's calculate maximum height. In calculating maximum height, we have two options. Option 1 is to use this portion of the projectile to calculate maximum height. So let's first calculate maximum height using option 1. So let me just write option 1 here. So in option 1, we need to use one of big 5 equation again, which is delta x is equal to v naught t plus 1 over 2 a t squared. Since we are only considering vertical components of the velocity with vertical displacement, instead of writing as delta x, we can write it as delta y for this problem. So in option 1, v naught is v naught y, and a is minus g, and delta y is h. And this is the value that we are interested in, and t is v naught sine theta over g. T is the value that we calculated in the previous question. It's not the total time, it's the total time divided by 2. So if you plug in these expressions, you get v naught y t minus 1 over 2 g t squared. Of course, you can just plug in like the expression for t into this equation and get h. You can do that and you can get h like that. But actually, there's option 2, which is much simpler. So if you consider option 2 is calculating maximum height using this portion of the projectile. So in here, of course, the big 5 equation is same. So delta y is v naught t plus 1 over 2 at squared. However, for option 2, v naught is vy at top, which is 0. And delta y is minus h because it travels h units downwards, so it's minus h. And a is, of course, minus g. And time is, of course, same as above. So if you plug in these values, that minus h is equal to 0 minus 1 over 2 gt squared. So h is just 1 over 2 gt squared. As you can see in option 2, you don't have v naught yt term here, so the calculation is much simpler. That's why I prefer option 2. So if you plug in the value for t here, you get 1 over 2 times g times v naught sine theta over g squared, which is 1 over 2 g times v naught squared sine squared theta over g squared, which is v naught squared sine squared theta over 2g. So this is the expression for So this is the expression for maximum height. Then let's calculate range. First of all, I told you that Vx is constant throughout the whole motion. So range can be just expressed as Vx times total time, where total time is 2V0 sine theta over G. So range is just V0 cosine theta times 2V0 sine theta over G, which is 2V0 squared sine theta cosine theta over G. Let me just write G in the middle, like this. Okay, then when range is given like this, then what angle produces the maximum range? So in the previous question, we found out that range is expressed as 2V0 squared sine theta cos theta over G, right? So rearranging this, we get V0 squared sine. Let me rewrite this. Rearrange. V0 squared times 2 sine theta cos theta over G. And since by double angle identity of sine, 2 sine theta cos theta can be expressed as sine 2 theta. So 2 times sine theta cos theta, 2 times sine theta cos theta can be expressed as sine 2 theta. So R can be expressed as V0 squared sine 2 theta over G. And sine 2 theta takes values between -1 to 1. So R is maximum when sine 2 theta is equal to 1. And we know that sine 90 is equal to 1. That means 2 theta is equal to 90 degrees. So theta is 45 degrees. This means that launch angle of 45 degrees would give you the maximum range. As you can see here, this figure shows projectile motion with multiple launch angles. And as you can see, a launch angle of 45 degrees gives you the maximum range. Thank you.